Hello! In this module, we will discover how to gather information about pins and more precisely, try to be connected to an UART Uart port. Recon the component. How is discussed in the previous part, in the PCB you can now easily identify all components from the pin like maker marks or package version. About component, you can easily get read information and get the exact model and version. Recon input-output. About communication, you can easily point out UART with 4 Ethernet port, SPI with MISO and MOSI port, and I2C with a SDA and ACK port. In order to improve yourself, you can test down some stuff at home and try to detect a communication port. Board analysis, gather information. From a component name and version, you may need more information to know what it is and how to get connected to it. Our answer could be found in the datasheet. This document, mostly available on datasheetcatalog.com, is a bible of the component. As we discussed in the previous module, you can find voltage, speed, and design. If you try to tear down and analyze your local shop item, and if the item has communication, you must learn about FCC. FCC provides tests before time to market for all items with communication functionalities. In the test protocol, most documents like schema or process are private, but some of them are public. You can find in public some photo, manual, and datasheet of components. All these documents could be found on the website fccid.io. Note that each FCC analysis has a unique ID. This ID is sometimes printed on the device. This can help you to find the correct analysis. Analysis static. About analysis, the goal is to make a mapping of all ports with component and trace. So, after JTAG or Uart port identification, you can try to extract live sensitive data. From storage component, you can try to dump data from EEPROM or desolder component. Analysis dynamic. In some cases, static analysis will give you nothing. Indeed, if data are stored encrypted and are clear in live, you will not be able to get any kind of clear text data in static. You must try the dynamic analysis. First, you can sniff the communication bus. On a storage component, this method will give you the possibility to get keys, password, or sensitive information. If you follow the same method on a component, you can try to get exchange. It could be very useful if you sniff a baseband of radio frequency chip. Second method is to manipulate the system via the Uart port. In most cases, the Uart port gives you access to the system via basic functions like a limited shell. From limited shell, you can try to do the privilege escalation to the root. The third method is to manipulate the microcontroller over debug interface like JTAG. With this kind of interface, you can access internal flash or RAM, extract the firmware or data, access the register to make live change and interact with the running code. Moreover, you can also flash malicious firmwares. Sniffing. In order to sniff communication on trace or component pins, you need a sniffer, of course. Sniffer is usually called a logic analyzer, and associated software allow you to identify protocol. Indeed, this software implements some functions to identify protocols. In the following pictures, the SALI logic analyzer is used and the communication is under analysis. On the right, you can find that the protocol I2C was analyzed and tried to be decoded. Uart identification. Step 1. In the following slides, you will learn how to identify Uart Pin, like VCC, ground, TRX and RX. I know that on DVID board, these ports are labeled, but in real world, they are usually free of label. Step 1 is to identify the Uart port. Uart has usually 4 pins, so on the board you should find 4 aligned pins. As we viewed in the first module, GND is for ground, VCC for voltage, RX to receive signal, and TX for transmit signal. Step 2. Step 2, get the ground. Ground is the same all over the board. So, from the power pin, you can try to get the continuity with a multimeter. If you have a multimeter, you can place it on continuity test mode. After, you can place the first probe on power source ground. With the second probe, you can try each pin, and if you can hear a sound, the current pin is ground. On the following picture, 0 on the multimeter indicates the continuity. So, 3 pins left. Remember to do ground identification with a board that has no power. Step 3. Step 3, get the VCC. VCC cannot be identified as a ground because the signal goes through all components, and each component will put resistance on the continuity signal. The unique solution is to power the board and try to get stable power on one pin. Place your multimeter in voltage mode and get the power of pin when you powered your board. The power could be 5 volt or 3.3 volt, depending on the wiring. On the following pictures, the pin on the right is VCC, because multimeter indicates 5 volt, so 2 pins left. Step 4. TX and RX pins are harder to identify. Remember that TX is used to transmit information. So, one pin should have 5 volt in interval. To identify the TX pin, you can place your multimeter as voltage mode and find if there is a voltage variation on one pin, like 3.3, 2.5, 1.6 or 3.2. If you find this behavior, the current pin is TX. Step 5. RX is the last one. You can identify it only with elimination because this pin only receives a signal. Conclusion. In this module, you have discovered how to get information about pin and more precisely, try to be connected to an unknown Uart port. Remember, communication port design like Uart equals 4 pins, SPI label MOSI and MISO, and I2C label like SDA or SCK. Thank you.